Good afternoon, students. Welcome to this video presentation. My name is Samuel Chukwuemeka, and in this video presentation, we shall be discussing logic and truth tables. We shall break this video segments into parts, and we shall take it one at a time. The area of logic is a vast area. And before we start, let's look at why we study logic. Why do we study logic? Logic is an area of mathematics. In fact, it's the basis of all mathematical reasoning. Any mathematical reasoning is associated with logic. It deals with that process of reasoning. You know, for you to say that this reasoning is correct or that is valid or invalid, you have to assess the logic. You have to assess the logic to see whether the reasoning is correct or incorrect, or whether the reasoning is valid or invalid, or whether the reasoning is true or a fallacy. Okay, now there are some scientists that we shall give credit for this topic. Of course, we see Aristotle as the father of logic. You can read about the history, but we also look at George Boole, the Boolean algebra, whereby you have the truth table, the truth value of either true or false. Like if you look at your logic circuit, if you look at your electric circuit, you see 0 or 1. 0 meaning off, which is false, and 1 meaning on, which is true. So George Boole did some groundwork here. Aristotle also did some work here. Another scientist that did some study of symbolic logic is Leibniz. So that is for the history of logic. Now, why do we study this? Logic is used in several fields. We use this reasoning in several fields. This topic will help you to reason well, to think about what you're saying, to think about whether a statement is valid or invalid. This topic will help you to detect errors or fallacies in reasoning or in statements. This topic will help you to communicate well. It will help you to clearly understand the decisions that you intend to make in real life situations. It will help you to understand it. So it's about reasoning. That's the main thing. It's about reasoning. And it could be seen that a lot of theorems in mathematics, a lot of mathematical formulas are derived from logic. Okay? So now, what are logical statements? We begin with the logical statements of proposition. What is a propositional statement? Now, a logical proposition or a statement is a declarative sentence. Declarative sentence that is either true or false. It can be both true and false. Okay, it's a declarative sentence that is either true or false. That is either true or false, but not both. Okay, if it is true, we assign it a truth value of uppercase T. If it is false, we assign a truth value of uppercase F. So if we look at a sentence, a declarative sentence means the sentence declares a fact. If that sentence you said is true, then we assign it a truth value of uppercase T. If the sentence is false, we assign it a declarative value of uppercase F. Now, how do we now illustrate these sentences? In the kind of logic we are going to learn, we see it as what we call symbolic logic. Symbolic logic. This is the kind of logic whereby you represent statements with letters or alphabets, variables. Okay? Is the kind of logic where statements are represented with letters, represented or denoted. You might say denoted with letters. And conventionally, we use a P, Q, R, S to denote statements, to denote logical statements. So these are what we use, P, Q, R, S. Now you might see T if it goes for 5 sentences. So we are going to look at these logical statements or propositions, and we will kind of look at their truth values, how many possibilities they have. So if we have only one sentence, we use P. If we have only one statement or sentence, we use P. If we have 2 sentences, we use P and Q. If we have 3 sentences or 3 statements, we use P, Q, and R. If we have 4 sentences, we use P, Q, R, and S. Statements. Let's be familiar with saying statements or proposition. If we have 1 proposition, we use P. If we have 2 propositions, we use P and Q. If we have 3 propositions, we use P, Q, and R. If we have 4 propositions, we use P, Q, R, and S. Okay, good. Now, the next thing we are going into is, are all sentences logical statements? I mean, do we consider all sentences in English, do we consider all of them to be logical propositions or logical statements? And the answer is no. We don't consider all sentences in English language to be logical propositions. And you ask me, why do we not? And I will tell you, in general, questions and commands are not logical propositions. Remember, proposition is the same thing as statement. Logical propositions or statement. Okay, let's now give an example. You know, if I say that the capital of Nigeria is Abuja, right? I don't need to write it. If I say the capital of Nigeria is Abuja, then of course, the capital of Nigeria is Abuja. So, because of that, it's true. It's a statement. So the truth value is true. If I say that that America gained their independence in 1776, then it's true. That means the logical statement is true. So the truth value is T. The truth value is T. The statement is true. But when I said, please, what is your age? If I say, what is your age? That is a question. That is not a logical proposition because it's a question. Or if I say, when last did you take a math class? Then it's a question. It is not a logical proposition. Or if I say, I want you all to be quiet, that is a command. So it's not a logical proposition. Or if I say, come here, that's a command. It's not a logical statement, or it's not a logical proposition. So let's also look at some other statements. If I say that the capital of Alabama is Hawaii, that is a logical proposition because it's a statement, but it is false. And because it is false, the truth value is F. Or if I say the capital of the United States is Seattle, Washington, that is also a statement, it's also a proposition, but because the statement is false, we assign it a truth value of F, but it's a statement. Okay, the only things that are not statements are questions, commands, and the like, Okay, so the next thing we will do now is let's consider truth values. And when you consider truth values, it now leads you into truth tables. Truth table is the tables that has the truth values of each logical proposition. So if we have only one statement, one proposition, that is P. Before I write this, I'll now say the number of when you have one statement, the number of responses, or the number, how many truth values can you consider is 2. You can either have a truth value of true or false. So the number of responses, or the number of possibilities, let me start putting the number of possibilities for one statement is 2, because that statement can either be true or false. So let me say now the number of possibilities of n statements of n logical proposition of n. Let me use something green here. I hope you see this one. Of n logical propositions is 2 raised to power n. And you ask me, what does this mean? How do I get this? Now, some of the things I'll teach here you might not see in some textbooks, but it's correct. Okay, it's correct. And if you have any question, feel free to make your comments after watching the video. But I will not teach you any wrong thing. I will not. Okay. Now, the number of possibilities of n logical propositions or statements is 2 raised to power n. What do I mean by this? If you have one statement, one logical statement, let's say logical propositions, number of possibilities. Like if you have one logical proposition, then the number of possibilities is 2 raised to power n, which is 2 raised to power 1, which is 2. And let's look at an example. Examples. If you have only P, you can either have P has been true or P has been false. Or I can write it this way. I can actually write it this way. And if you have P, you can have it as true or false. This is a better way to write it. Remember, P is a logical statement. So it can either be true or false if you have only P. Now, what if we have two propositions? You know, if we have only one proposition, then it's P. Let me put in parentheses, P. If you have two propositions, then it's P and Q. So the number of possibilities here is 2 raised to power 2, which is 4, right? So when we have two propositions, right, we can have when P is true and when Q is true. We can also have when P is true and when Q is false. We can also have when P is false now and when Q is true. And then we can also have when P is false and when Q is false. So these are the 4 possibilities we can have when we have two logical statements. The first, true, 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 false, false, true, or true and false. Now, you will now ask me, the next thing is, how do you know this? How? And the thing there is that when you have, of course, this first one is kind of straightforward. It's either true or false, right? Now, but the second one, if you consider it, is 4. So if you have this 4, consider when for P, when the first 2 are true, when you divide 4 divided by 2, 4 divided by 2 gives you 2. The first 2 will be true, and the last 2 will be false. Yeah. And then for this one, well, after doing 4 divided by 2 gives you 2, you do 2 and 2. Then for this one, because it has another one, divide 2 by 2 again, gives you 1. So you now have 1 true, 1 false, 1 true, 1 false. You do it that way. I mean, if you understand it this way, it's easy. It's easy, I think so. Now, if you have 3 logical statements, we have P, Q, and R, right? So this will now be 2 raised to power 3, the number of possibilities you can have. And that is 8. 2 raised to power 3 gives you 8. So before I just write it, you will now see that for P, if you do 8 divided by 2, is 4. So you have 4 truths, and 4 false for 8. So you have 4, 4. Then divide that 4 by 2. You have, for the Q, you have 2 truths, 2 false, 2 truths, 2 false, 2 truths, 2 false. Then divide it by 2 again for R. You have 1 true, 1 false, 1 true, 1 false, 1 true, 1 false, 1 true, 1 false, 1 true, 1 false. And you keep going like that. You need to understand this, because the next video, when we do truth tables, logical connectives, and truth tables, then you need this knowledge. Because when I'm listing it, you need to know why I'm listing it that way. Okay, so we have P, Q, and then R. So here, 8 divided by 2 is 4. 4 truths and 4 false. 1, 2, 3, 4. And then 4 false. Let me kind of use the line to separate this. 4 false. 1, 2, 2, 3, 4. Then for the Q, this 4 divided by 2. So 2 truths, 2 false, 2 truths, and 2 false. I mean, I don't know whether there's falses or truths, but I know there's nothing like truths or falses. So I'm just saying 2 false, 2 true. Okay, then R, these 2 divided by 2, 1 true, 1 false, 1 true, 1 false, 1 true, 1 false, 1 true, 1 false. And that is your 8 if you have 3 logical propositions. And we'll just stop at 4 because we PQRS, I think S is the you have up to 5, you know, ST, but we will just stop at S. So assuming we have four logical propositions or logical statements, and we have P, Q, R, S. So how many possibilities do we have? It's 2 raised to power 4, which is 16. So in this case, 16 divided by 2, you have 8 for P. You have 8 true, 8 false, divided by 2 again. For Q, you have 4 true, 4 false, divided by 2 again. You have 2 true, 2 false. We keep it listing like that. And S, 1 true, 1 false. Yeah, because if you consider this means when P can be true, Q can be true, and R can be true. Here, P can be true, Q can be true, and R can be false, you know. So these are the possibilities you have. Now let's do the last one. If it's 4 statements. So if it's 4 statements, P, Q, R, S. And because it's 16, if you divide it by 2, the first one, you have 8 trues, 8 false. True, 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 true. 1, 2, 3, 4, 5, 6, 7, 8. Then we have false, 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 false. 1, 2, 3, 4, 5, 6, 7, false. Okay. Then T is now 8 divided by 2, 4. So this is true, 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 false, 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 true, 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 false, 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 false. And 4 divided by 2, 2. True, true, false, false, true, true, false, false, true, true, false, false, true, true, false, false. These are the possibilities. Then S, 2 divided by 2, 1. True, false, 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 true, false. So this tells you that when you have 4 statements, the first one can be true, second can be true, third can be true, and the last can be true. First can be true, second can be true, third can be true, last can be false. I mean, these are all the possibilities you have. So, thank you so much, students, for listening to this first session. We don't want the video to be so long and boring because it's long. I mean, my class shouldn't be boring anyway. So, watch out for the next video segment where we shall talk about the logical connectives and the truth tables. We'll look at negation, disjunction, conjunction, biconditional, and the conditional. All right, thank you so much, students, and you have a great day.